So why is the night sky dark when there are more stars than grains of sand on Earth? In fact, if nothing else in physics changed, the entire sky should glow as bright as the surface of the sun, all night, everywhere. That sounds absurd, but it is what you get if you imagine a universe that is infinite, filled evenly with stars, and has existed forever. In such a universe, every line you point into the sky would eventually hit a star, and distant stars, though individually faint, would be so numerous that their light would add up to match the brightness of nearby ones. Yet we see mostly blackness between a few scattered points of light. So our everyday experience of a dark sky is already telling us that the universe cannot be both infinite in age and simple in structure, and understanding exactly how it fails. Those expectations is the key to our question. The darkness above your head is a measurement of time. Light has a finite speed. It travels about 300,000 kilometers every second, which we know from laboratory measurements and astronomical timing. A light year is the distance light travels in 1 year. So when we look at a star 1,000 light years away, we see it as it was 1,000 years ago, not as it is now. The part of the universe from which light has had time to reach us since the beginning of cosmic expansion is called the observable universe. Anything beyond that distance is simply unlit from our point of view because its light has not arrived yet. If the universe has only existed for a finite amount of time, then there's only a finite amount of space whose light can currently reach us, and that alone already chips away at the infinite sea of starlight that would otherwise make the sky blaze. Now comes an even trickier problem. Is the finite age of the universe enough on its own to keep the sky dark? Imagine shrinking the sun down to the size of a grain of sand and placing it in a football stadium. On that scale, the nearest star would be only a few tens of kilometers away, far beyond the stadium, and most of space would still be empty. The intensity of light follows what physicists call the inverse square law. When you double your distance from a source, its brightness drops by a factor of 4 because the light spreads out over a larger area. That means nearby stars dominate what we actually see, and the vast majority of stars are so distant that, even within our observable universe, their individual contributions to the sky's brightness are tiny. This mismatch between the sheer number of stars and the extreme emptiness between them is part of why most directions you look do not land on a star at all, softening but not fully resolving the original paradox of the dark night sky, historically known as Olbers' paradox. Space itself stretches the light into invisibility. Observations of distant galaxies show that their light is systematically shifted toward longer wavelengths, a phenomenon called redshift, because the colors move toward the red end of the spectrum. The simplest explanation, strongly supported by many independent measurements, is that space is expanding. The distances between galaxies grow over time like dots painted on the surface of an inflating balloon moving apart, even though the dots themselves do not move much relative to their local patch. As light waves travel through this expanding space, their wavelengths get stretched. Each photon, the basic particle of light, loses energy as its wavelength increases, sliding from visible light into infrared and eventually into microwave radio waves that our eyes cannot detect. Here's the surprising twist. The universe actually is filled with an almost uniform glow, but it shows up as the cosmic microwave background, a bath of microwave radiation left over from the hot early universe, directly measured by satellites. The sky really is bright, just in a color we cannot see, which hides much of the starlight from our naked eyes. At this point, we can ask what the dark sky is really telling us about the universe's history. For the sky to be dark and visible light, our earlier assumptions must fail. The universe cannot be infinitely old, purely static, and filled with unchanging stars. Modern cosmology, based on observations of galaxy redshifts and the cosmic microwave background, indicates that the universe is about 13.8 billion years old, has been expanding the entire time, and that matter clumps into galaxies where stars are born, evolve, and die. Many potential stars have not yet formed, and many that did form have already burned out, so there was never a time when every line of sight was packed with shining stellar surfaces. Another counterintuitive result is that as cosmic expansion accelerates, more and more galaxies will slip beyond our observable horizon, and in the far future, the night sky will become even darker for distant civilizations, hiding most evidence of the broader cosmos from them. So, the darkness we see now is not just an absence of light, It is a fossil record of a universe that had a hot, dense beginning and has been thinning and stretching ever since. The real answer is that the night sky is dark because the universe is not eternal and unchanging, filled uniformly with stars. Its finite age limits how far light has had time to travel, so we only see a bounded region. The extreme emptiness of space means most directions do not point directly at a star, and the expansion of space redshifts much of the ancient light into wavelengths our eyes cannot detect. If we could see microwave radiation instead of visible light, the sky would appear as a nearly uniform glow from the cosmic microwave background, and Olbers' paradox would feel completely different because we would not experience the night as dark at all. What looks like an obvious, everyday fact, that the sky is mostly black, is actually a precise clue that the universe had a beginning in time and has been dynamically evolving ever since. So when you step outside at night and see those few scattered stars against a vast darkness, you're not looking at an empty void. You're reading a long, physical argument about the structure and history of the cosmos, written in light and absence of light. Like, if this was interesting, hit the subscribe for more, and turn that notification bell on.